So, hi everyone, good evening. I hope all are doing well, and I hope I'm audible. Can anyone please acknowledge in the chat section? Okay, thank you, thank you so much for that acknowledgement. So, hi everyone, this is Abhishek. So, I'll in the next 1 hour, we'll be talking about the getting started with STM32, which is based on Cortex M4 series, Cortex ARM-based Cortex M series. Okay, so in next 1 hour, what we're going to do, we're going to learn about basic architectures, what is ARM, what are its features. Then we're going to discuss about STM32 and its portfolio. After discussing about the portfolio, the hardware component, then we'll move on towards our lab session, that is getting started with STM32 CubeID, which is equipped with multiple tools, like it is also integrated with CubeMX and a lot of other, you can say, tools. So we are starting with the session. So I'm sharing my screen. Okay, so today's webinar, it's as it is given, like getting started with ARM-based Cortex M4, STM32. Just a second here. So today's agenda. So today we're going to learn about ARM introduction. What is ARM? Overview of ARM, its services. What are the latest trend in the ARM architecture? What is Cortex M? Because that will be our focus area. Okay, a feature of ARM Cortex M family. This will be our focus area in this presentation. Then we're going to discuss about what is ST Microelectronics, what are the technology and solution that is provided by ST Microelectronics, products and services, what are the latest trend, what are the latest launch by ST Microelectronics. And we're going to study what is CubeMX, because whenever you start with like STM32, you must be aware about its ecosystem. So ST has developed their own ecosystem, which is free of cost and which is available with each and everyone. It is open source and it is easily available on ST website. Okay, so we're going to install STM Cube ecosystem so that we can code and work on the various projects. Then after learning about various concepts, tools, and configurations, we're going to have hands-on lab session on STM32 Cube, in which we're going to give you the overview, embedded tools, and what are the software that are available. So as you know, this is about the ARM. Now what we are discussing, what is ARM? Okay, and how it has created a revolution in electronic chip manufacturing. Okay, so earlier, as you can see, I'll just yes. So earlier it was ARM. Now it is acquired by NVIDIA. This is the news that you all must have seen. Yes. So you all must have seen that latest news, like ARM is acquired. Now NVIDIA has acquired ARM. So what is ARM and how it was established? So ARM, the full form of ARM is Advanced RISC Machine. Okay, in short, we call it ARM. Okay, so it was, you can say, it was invented, the company, there was multiple companies which were involved in creating this architecture, which is known as ARM. First of all, you have to make sure whenever anybody asks what is ARM, what is controller, so you have to remember one thing, the differentiation between architecture and microcontrollers or microprocessors. ARM is an architecture. Okay, it's an architecture, and semiconductor companies like ST and other semiconductor, they take license from ARM in order to integrate that architecture into their chipset. So you all have to be clear, it's an architecture. ARM is an architecture. It's not a processor or it's not a controller. It's an architecture which semiconductor take license from ARM in order to create just a second. In order to create, you can say, STM32 chips or any other chips. Okay, so it was a joint venture between Acorn Computers, Apple, and VLSI Technology. So what are the services of ARM? Okay. So as you can see, ARM is the world leading technology provider of providing silicon IP for intelligent system on chip at the heart of the billion of devices. That means it is an architecture that is available in every embedded system, whether you talk about mobile phone, whether you talk about smart devices, whether you talk about any technology based on embedded system. ARM is a core that is being utilized by the semiconductor industries. Okay, so as you can see, the technology is growing. So the ARM architecture has come up from very, you can say, in the upcoming slide, we're going to see how the ARM has grown up, and it is providing latest features in order to work on your applications. Okay, whether you talk about IoT, whether you talk about variables, whether you talk of 5G security, each and everything is being provided by ARM. Okay, so now this slide is very important to know about what is ARM processor family. Okay, so right now, as you can see on the screen, ARM processor family. Cortex A, which is known as application specific. Second category is Cortex R, which is real-time processor. Cortex M, which is microcontroller specific. Our focus is on Cortex M series, but we're going to have brief information. What is Cortex A? What is Cortex R? What is Cortex M? So combined is ARM. Okay. So Cortex A series is a very high-end processor which is used for mobile computing. For example, your mobile phone, okay, your set-top box, servers, all these applications are based on Cortex A processors. Okay, you must have heard of Raspberry Pi and other processors. So that is based on Cortex A architecture. Okay, when we work on Cortex R architecture, these are very high performance real-time operating systems. Whenever we work on real-time applications such as you can say digital camera, mobile-based drive disk, even in automotive sector, powertrain, these applications are based on Cortex R architecture. And when we say Cortex M architecture, it is microcontroller specific. That means if you're using microcontrollers like STM32 or any other 32-bit microcontroller, so that is equipped with Cortex M. So any application based on microcontroller, so that is based on Cortex M. Okay, so just to give you just to brief you up, like Cortex A is application specific, or you can say mobile phone computing, mobile computing servers. Cortex R is a real-time application which is used in like hard drive controllers, automotive powertrains. So that is where we use Cortex R architecture. And whenever we work on Cortex M, like for example, microcontroller specific applications, so we use Cortex M architecture. Okay, so this is a very important slide, and this is very important thing that you should know whenever we work on Cortex M architecture. Okay, so this is the ARM family. As you can see, screen is divided into two parts. The first part is the classic ARM processor. Okay, ARM 7, ARM 946, ARM 926, ARM 11. So these are the classic ARM series. Now, what was done with the Cortex processor? This was developed from scratch. As you can see, Cortex M architecture is a separate category of ARM family, and you can see Cortex M, M0, M4, M7, R7, A15, A17. So these are the complete, you can say, Cortex series, and this is the real, you can say, ARM series. So the previous series that ARM used to have. So latest trend in the ARM, as you can see, they are working on various architectures as the technology is growing. So they are providing various architectures based on in-demand industry or in-demand requirement from the industry. Okay, so as you can see, microcontroller processor category, the latest processor which is launched by ARM is Cortex M35P, Cortex M23. So this is the latest, you can see, architecture that is launched by ARM. And just to give you one more information, like this is the Cortex M0 family, which is based on 90 micrometer, and similarly it has grown up from M0, M0 plus, M3, M4, and M7. Okay, so now its latest series are also included. So this is the series of Cortex M0 series. Okay, M0 series, then M0 plus, M1, M3, and M4, M7. So this is how the processor, and it is increasing like they are working on latest architectures, and they are increasing their architecture, and those architecture is being you can say is being adopted by the semiconductor industries in order to provide you the latest feature required for the product development. Okay, these are the basic thing, like where ARM is used. So whenever you're working on product development, like smart home applications, smart car applications, smart tablets, television, wearables, smart city, all these products is based on ARM architecture. Okay, so whenever we talk about embedded systems, so these products consist of ARM, and with the help of these architecture, a lot of products are being developed in the industry. Okay, so now again, this slide is very, very important. Okay, so as you can see on the screen, the Cortex M0 series, then Cortex M3 series, Cortex M4 and M7 series, Cortex M4 FPU, that is floating point unit, Cortex M7 floating point unit. Now, in this slide is why this slide is very important, because you can see the instruction set which is there in Cortex M0 is compatible with Cortex M3. That means if it is easy for you to switch from one processor or one architecture to another architecture. And the same thing is available in STM32 controller when we're going to discuss about STM32 controller. Okay, so Cortex M0 instructions, the instruction that you are seeing on the screen is compatible to M3. M3 instructions are compatible to M4 and M7. M4 and M7 are, instructions are compatible with Cortex M4 FPU. And these instructions combinedly is compatible to Cortex M7 FPU. Okay, so that is why we say the controller which is based on Cortex series are compatible to each other. Suppose I'm working on Cortex M0 series, so it is easy for me to work on M4 because the instruction is common and you can easily migrate from lower controller to higher controllers. Okay, so this is just a brief about ARM architecture. Now, what we're going to discuss, about ST microelectronics and its registration process. Okay, so let me just okay, so I hope my screen is visible. So this is the ARM STM32 ST microelectronic website. Okay, I'll just start from very basic. So whenever you go to st.com, it is like each and every information is available on this, you can say, on this website. For example, if I hope you have seen in the group that you have to download STM32 CubeID. So in similar way, you can easily search in these buttons. You can simply type and you can search any application that you want to install. So I have written STM32 CubeID. So there is one application, okay, CubeID, and this is a tool that we're going to use. And these tool, you have to install this, you can say this tool according to your computer specification. Okay, according to your system specification, you have to install this tool. So as I'm using Windows, so I have installed this tool. And if you're using a Mac, if you're using Linux, or if you're using Debian OS, so you can like install according to your specification or according to your system requirement. Okay, so we will be working on STM32 CubeID, which is equipped with CubeMX and various other features. Okay, so this is about the CubeMX that we are talking about. Okay, so CubeID. And you have to install these softwares. I hope you all have seen the link that we have shared in the WhatsApp group. So please install this tool so that it will help you to be in sync with what we are learning. And of course, we're going to have more upcoming sessions in the coming time. So first step is to install CubeID. Okay, I've already installed CubeID. So I'll just open it up. So this is how the CubeID look like. Okay. So as you can see, this is a CubeID. First step, now what we are doing, we are moving towards how to work on CubeMX. What are the application of CubeMX? What are the steps that you have to follow in order to develop the code, in order to work on any instruction? So now the steps are very, very important. Each and every step you all must remember to work on STM32 ecosystem. Okay, so this is the CubeID, which you have to install from, you can say, from ST website. Okay, get the latest version and just install it. So this is the workspace. The first step is to do the configuration, the microcontroller configuration. Okay, the first step is go to File, New, and there is an option called STM32 project. Okay, there is an option called STM32 project. From this, you can say this tab, CubeMX will be open. Okay, So it will going to switch from this workspace to CubeMX, and the CubeMX will help you out to work on the controller. Okay, to work on the configuration, whether you want to work on GPIO, whether you want to work on ADC or any other controller. So just to showcase, we'll be using this board. Okay, so as you can see, this is the touch screen, this is the microcontroller. Okay, so this is the USB, and here is the LEDs. The buttons are available. This is the LED RS232 ports, Ethernet. So we'll be going to use this board for our you can say webinar. Okay. Okay, so the board name is the board that I've shown you. The controller name is STM32. Just a second. So this is the board that we are using. So it is the board name is STM3241G eval, and the controller that is there in the board is STM32F17 IGH6. Okay, so this is the controller that we are using. Before that, yeah. Yes, Shams, we'll send the software link after this session. Okay. Alternatively, just okay, I'm sharing it in the WhatsApp group itself. So I've shared the you can say the CubeID HTML page. You can easily install it. Okay. So now everyone, what happens is just a second. I'm just copying this controller name. Okay, so this is the controller STM32F17IG, which is available in this board. Now, what happens is many a time, anyone who is working on STM32 or they are working on first time working on controller, they get confused. What is data sheet? What is reference manual? What is application note? Okay, so whenever you search for this, like I've searched this controller. High perform. This is the STM32F4 controller which we are working on right now. So whenever you go for the overview, these are the tabs. These are the specification of the controller that you have shortlisted. So it has all the features are available in this page. And most importantly, whenever you are working on any controller, you must be aware of the documents. What sort of documents that are available? Okay. So first important documentation is the data sheet. Okay, you can easily download this data sheet. So data sheet will give you the information what sort of peripheral that is available in this controller, what are the feature of those you can say of those peripherals, and if you are working on coding part and if you want more detailed information, then you have to go to reference manual. Okay, so reference manual is most important when you're working on STM32 because it consists of each and everything from at register level. So I'll just for demo purpose, I'll just open it so that you all can get the idea. Okay, so this is the reference manual. In the reference manual, suppose I want to work on ADC, okay, or I want to work on GPIO. Okay, so I just open the GPIO. All the features is available in this reference manual itself. Okay, so if you go to this section, okay, if you go to this section, all the registers are available. Okay, and all the register details are also available. See, I'll just zoom it. Okay, GPI register, like you want to work on output mode, input mode. So register level information is available on reference manual. Please remember this thing because most of the time any new learner on controller get confused. So reference manual consists of register level information. And if you want to check the specification, what sort of controller is having this specification, then you have to refer to the data sheet. Okay. Now we are moving towards the CubeMX again. So our controller name is just. Okay, so this is our controller, STM32 F17IG. Okay, I'll just. You have to give the project name here. So I'm just giving a project name called demo. Now, what is the tool? What is it doing? Now it is installing the, or it is embedding the CubeMX file. Okay, so next screen that you're going to see is the CubeMX file, in which you're going to you can say you can easily configure all the peripherals. So it will take a certain, yes. Just a second. So it's loading the CubeMX file. It will take 10 to 20 seconds maximum. So this is your pinout view. This is how the controller look like. Okay. Okay, so this is the you can say the controller. Okay, and these are the pinouts that you see on the left hand side. Okay, on the left hand side you will see the peripheral that is supported by the controller. That is supported by the controller that we have selected. So with the help of this CubeMX, the best advantage is that you don't have to go to the reference manual, or you don't have to go to the data sheet. Everything is available in this screen itself. So this is the best advantage to work on CubeID, or you can say you on CubeMX. Each and everything is available. Suppose I have shortlisted this controller, and you can see on the left hand side ADCs, how many ADCs are supported, how many timers are supported, the connectivity, like it's about CAN, Ethernet, external memory, that is FSMC, I2C, SPI, UART. Multimedia, suppose you want to interface camera, so it is having protocol called DCMI, digital camera interface. I2S, in case you want to inter IC sound communication. Okay, so on the left hand side you will see each and every configuration. Okay, so that is why you don't have to go to any data sheet, any reference manual. Everything is available in this controller itself, in this screen itself. Now this board, I'll just show this. Yeah. In this board, if you see right now, if you see this, there is one LED that is glowing. Okay, so we're going to have this small activity of LED blinking. So these four LEDs, the bottom of this button. So these four LEDs are connected to the controller. Okay, this is connected to the controller on predefined pins. For example, LED1 is connected to PG6, LED2 is connected to PG8, LED3 is connected to PI9. Okay, so what we're going to do, we're going to select that pin. Now what we are doing, we are selecting the peripherals. We are starting with GPIO. Okay, in that GPIO, we are selecting PG6 and PG8 for LED blinking activity. Okay, so now there is one more feature on this screen. There are a lot of features that we're going to discuss about this screen. As you can see, it is not easy to search a pin number. Okay, so here is a feature of search button. What I can do, I can simply write PG6. Okay, and you can see easily the you can say the pin is blinking. Okay, I'll select this pin and I'll set it as GPIO output mode. Okay, so just a second.
Not able to see the screen.
Oh, okay, sorry. Yeah. Yes. So I'll just reset it again. It's visible now?
Yes.
Okay. Okay. Thank you for that acknowledgement. So what I was telling, like there is a search button. Okay. So as you can see, there are a lot of pins that you are seeing on this controller. But how to shortlist one pin? So there is a tab called search. You can simply write EG. You can say E6. Okay. So you will see the LED is blinking. Sorry, the pin is blinking. It is giving the indication that here is the pin PG6. So I'll go to this PG6 and I'll set up as GPIO output, because on the board this pin is it is internally connected to LED. Okay, so PG6 is something that we have shortlisted. Again, we can also shortlist PG8, another pin. Okay, what we have done, we are again selecting as GPI output mode because LED is in output mode, and we can easily select these two pins. Another thing, like these are the GPIO that we have shortlisted. Now let us do one activity. Let's because as we are doing a demo, let's select USART1. So I've selected GPIO USART1, and easily these two these two pins of USART are activated. One is TX mode, one in RX mode. Okay, just yeah. So you can easily these two pins are selected. The one more best feature is you can easily select the baud rate. Earlier, how we used to do, we used to go to the register, we have to change the baud rate. Now I can easily set the baud rate from here itself. I don't have to go to datasheet. Okay, so it is now 9600. Okay, simply if you want to if there is a like word length 8-bit 9-bit, you can easily select from here. If you want to include parity, you can include it from here. So you don't have to go to any datasheet, any reference manual. Everything is available in this tool itself. Okay, so right now what we have done, we have selected two GPI output and we have selected USART. Okay, USART1 in asynchronous mode, in which what we have done, we have set up 9600 baud rate. Next, what we are doing, simply again as per your convenience or as per your application, you can simply select any of the peripheral. Like if you want to select the peripheral timer, if you want to select the ADC, you can simply select those peripherals. So Shams, it's depend on the application that you're using. So parity bit, yes, benefit of using odd and even bit. So it is you can say the parity bit, this redundancy check, it is totally depend on the application that you're working. If that supports even an odd parity bit, then you have to set up. Otherwise, you can keep it none. So it totally depends on the sensor that you're using or any application that you're using. So accordingly, you have to select odd, even, or a none. It is totally application dependent. Okay, so this is you can say these are the configuration that we have done. We will keep it simple because you can select in lot many peripherals. The next is the clock configuration window. Earlier we used to set up the registers. Now what we have to do, we can simply, as you can see on the screen, it is 168 megahertz. That is a maximum frequency that a controller can support. Okay, and to give you the information, the clock sources, the STM32 has the clock source like a low speed internal, high speed internal RC. These are the internal, you can say, clock frequencies that are available. So for example, this is set up as, and this is PLL. What is PLL? It's a phase lock loop which multiplies and divides the input frequency in order to give you the desired frequency. Suppose I want my application to work on 48 megahertz. So simply I have to write here 48 megahertz and I just have to enter. And I have to click OK. Now this clock configuration tool will automatically going to configure itself on 48 megahertz. Okay, now the clock frequency is also ready. Now your system will going to work on HCL frequency will going to work on 48 megahertz. Suppose you want to set up some external crystal then you have to go to RCC and you have to select just a second, system core. You have to go to RCC, and here from here you can enable external crystal. Okay, but we are using internal crystal, so that's why we have selected high speed internal. In your application, whenever you are developing the product and you want to use the external crystal, so you have to enable it from here. RCC, reset and clock circuitry, and you can easily enable from here. Okay, so this is the second step, the clock configuration window. The third step is to generate the code. Right now, the configuration that we have set up, we can simply generate the code. And these are the configuration. Which tool you want to use? We are using CubeID, so we want on system workbench from STM32. Okay. The second is code generator files. Now, this is the important setting. Suppose if you want to use you want to copy all the library file in the project, you just have to select this. Now, if you select this, all the peripherals, their libraries will be available, but that will make your code bulky. Okay, so we have to get only the required library files. Okay, so that's why. Yes. Yeah, Manish, we will help you out in this for sure. So copy only necessary files. Okay, so you just have to copy this necessary. You just have to select this only. You have to keep this settings default. You don't have to change these settings. Okay, so I'll just before generating the code, I'll just give you the again recap the things. First, in pinout mode. In pinout mode, you can select any pin as per your desired application. Okay, suppose I'm selecting one more PC7. Okay, PC7. I'm just selecting it again. I'll go to this pin, and you can see there are a lot of peripherals that is supported by this pin. Okay. Okay, there are a lot of peripherals that is supported by this pin. So we are selecting GPI output. Now, anyone from the audience can answer how a single pin supports multiple peripherals. What's the concept behind that? Anyone from the audience? They can use the chat box or they can unmute themselves. Anyone? Yes, so mux demux is one thing that is behind that feature. Okay, so that is called an alternate function. A pin can perform multiple, you can say, it can support multiple peripherals with the help of mux and you can say demux. But how it is connected, it is the concept is known as the alternate functions. Alternate functions means a pin can support multiple peripherals, and with the help of multiplexer and demultiplexer, which is available inside the controller, can switch between the peripherals. Okay. One more thing that I just want to, one important feature. Suppose you have selected it as, you have selected 10 GPI output, and again GPI output. Suppose you have selected 20 GPI outputs. So you will get confused which pin is performing what kind of function. Okay, so here is the solution. The pin that I have shortlisted, I'll go to click on this pin and I'll write enter user label. Okay, so I can label that you can say pin. Okay, what I can do, I can simply write LED 1. So this pin, you can see if I zoom it, it is now known as LED 1. Similarly, if I select this pin, I'll go to user level, I can select it as LED. Okay. Now it is known as LED 1, LED 2. Simply you can name anything. Suppose any pin is connected to LCD, you can give LCD pin 4, LCD pin 5. Any sensor is connected, sensor 1, 2, sensor 1 ADC, sensor 1 DMA. So in similar way, you can give the names to the pin. Okay, so this is a very important feature. So what we have done, we have shortlisted the GPI output, we have shortlisted the USART. Next, what we have done, we have given the clock, desired clock for the controller. The third is project manager. In the project manager, lot of configuration are available. Okay, the project name, this is by default, it has already set up, so you don't have to change this thing. Where you can give a change, when you want to get the all the you can say all used libraries in the folder, or you want every pin to be set up as analog, because when the pins are set up in analog, so the power consumption is very less. So it is a you can say it is a function, it is available by default here. If you click on this, every pin will be marked as an analog, which is unused. Okay, so after after configuring each and everything, now what we're going to do, we're going to generate the code. Okay, so I hope this button is available. Everyone can see this button, device configuration tool, code generation. So we'll click on this and it will generate the code. Okay, so you can see the code is being generated. All the configuration that you have done on CubeMX, now that the configuration that you have done is now available on your screen. Okay, even the baud rate that we have set up, like 9600, the baud rate is available. Word length is available. Stop bit, parity bit, we have kept it none. So every configuration that you have done in the CubeMX is now reflected in your code. Okay. Important thing that we have to discuss is here. Apart from that, remember we have configured LED2 pin. Okay. So now that pin is known as LED2. It has become a macro, whatever you have defined in the code itself. Okay, so whatever you have defined in the CubeMX, even the macro in the configuration will be reflected in your code. Okay, let us understand this architecture. And everyone, there are a lot of, you can say, configuration and very important key point before starting your code in this workspace. You will see users to you have to write your code in these sections. Okay, user code begin include, user code end include. That means if you want to include any header file, so you have to include in this section. Why? I'll give you the reason. If you write code apart after the end, code end, okay, then if you go back to the CubeMX to configure one more pin to regenerate the code, then your code will be removed. Okay, so you have to make sure you're writing your code in this section. You can write as many as things you want to write in this area. Okay, so this is for header files. Similarly, this is for you can say another private variable, private definition that you want to define. Okay, private functions, private variable that you want to define, anything like suppose we are taking int a. Okay, so you have to define in this section itself. Okay, private function prototypes, you have to write it here. Any function that you have to write before main function. Okay, so you have to make sure that you're writing in between user code begin, user code end. This is very, very important. Otherwise, while regenerating your code will get removed, whatever you have written. If you have written anywhere else apart from these user code definitions, then your code will get erased. Okay. Similarly, in Int Main, you will see another section where you can write your code. If you want to initialize something, you can write here itself. Okay. Here comes the while loop. In while loop itself, they have also given the space to write your code before while and inside the while for infinite loop. Okay. And if you want to define any function, like any custom function, so you can define it here itself at the end of the file. Okay. So these are very important steps. Whatever you are writing, you have to make sure that you write in with begin and end section. Okay. So this is the GPI configuration that we have set up in the CubeMX. It has enabled both the pins. Okay. This is the UART structure, UART configuration that we have defined in the CubeMX. Now it is available in the code. Okay. So this is about the main file. Now, where are the other files? How should I how should I start writing the code? On the left hand side, if you see on the left hand side, there are, how will I know where the code is written if we remove the comments? So you don't have to remove the comments. Okay, this is the by default configuration. You don't remove this, otherwise your code will get erased. So you don't have to write this, like for example, if I have to write in this section itself. Okay, you don't have to delete it. This remains the same thing. Pranjal, whether I have answered your question? Okay. So remember everyone, we don't have to remove these commented section because it's an indication for this link to this file where you have to write your code. Okay. You start begin and end, and you have to write code in between. Similarly, for private variable, as like I have written int a, so I can write here itself for private variables. For prototyping, for function prototyping, I can write here function and with start, begin, and end. Okay, so I have to make sure these steps, where in the while loop we need to put our code. Yes, so I'm coming in that section. So in the while loop, suppose you want to start your code. Suppose you want before the while loop. So there is a function called user code begin while and user code end while. So you can write it here. Okay. Suppose you want to run it on infinite basis. So here is the space. User code begin section 3. User code begin end section 3. Okay. So you have to write your code in this area. Okay, you can write as much as code you want to write, but you have to make sure you don't remove these comments, because your code will be combined and regenerated based on these comments. We're going to have a short demo right now in order to see how it works. Okay. Well, Nancy, I hope I have answered your question. Any doubt? Okay, okay. By the way, we'll have one demo right now, so you'll get the clear picture how it works. Okay. So next is, where are the driver files? Okay, where are the files where I could see the code? Where are the functions from where I can get the functions? So on the left hand side, there is a folder called driver. In driver, there is a folder called HL drivers. If I go to HL driver, then there are two more folders: include files and source file. Okay. Suppose now what activity that we are performing, we are going to blink the LEDs. So I want to see what sort of functions that are available. Okay, so I'll go to this include function. I'll go to gpio.h because we have configured GPIO, and in this gpio.h, at the end of the file, you will see the code. You will see the function. Okay, so this is the function, you can say, prototypes that are written. Now I want to check what is written in this you can say in this function. I'll go to I'll click on this. I'll go to open declaration. So it will migrate from .h file to .c file in order to get the information what are the parameters that I have to write. Okay, so every function, so library files is written in this way. Every function will going to have its information above the code. Okay, above the code. Suppose what needs to be written in GPIO X is written here. So GPIO X, where X is from A to K or A to I. That means port number, port GPIO A, B, C, D, E, F, G, H. Which port needs to be used? We have to define it here. The second is GPIO pin. So GPIO pin, as you can see, it defined the port pin to be written. Which pin we want to initialize it here. Okay. The third is pin state. Pin state means whether we want LED to be on or LED to be off. Okay. Any doubt in this, anyone? what exactly we are discussing is how to know about the function, what is written in the function, what are the parameters of this function, and where from where I can get the functions. Okay, so GPIO.h is the area where you can see the function, which function you have to use. Suppose write pin, because we are using GPI, you can say output. Suppose you're connecting any sensor, then you can use GPIO read pin. That means you can read it from the sensor, whether you're connecting temperature sensor, humidity sensor, or any other sensor. So you can read it from GPIO underscore read pin. Okay. So right now what we have to do, we have to write it on the port. That means we have to make the LED on and off, on and off. What we are doing, we will going to toggle the LEDs. Okay. So I'll just copy this function. I'll go to this. Now, very important thing. What I'm doing, I'm writing the code in the user code begin and user code end. Okay. User code begin and user code end. First is which port number I have to define. So it's GPIO, GPIO G, because we are configuring GPIO G. GPIO G LED 1 is connected to GPIO G. LED 2 is connected to GPIO G8, and LED 3 is connected to I9, and LED 4 is connected to C7. Okay. So what I've done right now, I've got the port number. Next point is I have to get the pin number. Okay, so which pin I'm initializing? I have initialized GPIO 6. Now what I want this LED to be on. So I have set, I'll set this pin as GPIO underscore pin underscore set. Okay. So this is the initialization of one pin. What I'll do, I'll just copy paste this thing so that all the three pins can be on and off at the same time. So another pin is connected to GPIO pin 8, and the last pin that we have initialized is C7. Okay, so with this function, all LED will be on. Okay, so let's first run this code, or alternative, what we can do, we can just add delay. So there is a function called HL delay. Sorry. There is a function called HL delay, which is a predefined functions, and you can add a delay. Like for example, if I write 1000, so it will provide me the delay of 1 second. Okay, so I'll just again copy this file function and paste it. So first, when we are doing LED blinking exercise, yes, HL, yes, HL is actually the hardware abstraction layer. So it is the library file developed by ST. Okay, HL is hardware abstraction layer. This is the layer that is written on the controller. Why ST has come up with the HL layer is because you can easily migrate your code from one controller to another without changing your source code. Okay, for example, if I'm working on STM32 F2 and I want to migrate from F2 to F4. Okay, so using HL library or using hardware abstraction layer, I can easily switch from one controller to another without changing the code. In other controller, you must have seen you have to change the code whenever you're changing the controller. But in STM32, your code remains the same. Okay, because these are written on HL. HL is hardware abstraction layer. Okay, so this is the library file developed by ST. Okay, now what we are doing, we are just pasting it. So the activity, yes. Okay. Okay, so now what we are doing, we are performing the activity LED blinking. Okay, so what I have done, I have written the code in begin and end section. Okay, so I have written code here. Next is now what we have to do, we have to build the code. Right now it's getting built, so it is getting compiled. Okay. Now I have to first what I've done, project build. Now what I'm doing, run debug as HAL. Oh, sorry, STM32. See, now we are debugging the code. So what will happen? The screen will move towards the debugging section. So everyone, this is the debugging section. Now the next step is to run the code and see whether your application is working or not. So there is a button called resume. So you just have to click on this and see your code is LED is blinking. Whether everyone is able to see this? I hope, yeah. Just a second, I'll just. So if you see the LED blinking code, so these three LED are on, getting on and off. Okay, so what we have done, we have written a code in which three LED will be on and off after 1 second. Okay, so whatever we have written, I'll just share my screen again. So whatever we have written, in the while one section, the first three LED will be on, then wait for 1 second, then three LED will be off, then wait for 1 second. The same is done in this board. We have compiled the code, we have downloaded this code into this controller, and you can see your application is working. Mahesh, whether it's working now, whether you are able to see the screen, the LEDs? Okay. So this is the basic application on STM32. Now, next, what we're going to see is this is the complete debugging section. Okay, where you can pause your debugging to see where is the code. I can play it again from here. Okay. Okay, so now next, yes, there is a question, what are the parameters are available in API for LEDs? I'm not getting your question, can you please elaborate? Okay, what we're going to do, we're going to just complete our webinar. Like there are 2 to 3 more features that we're going to discuss, then I'll take the questions. Okay, so debugging section is extremely important, for the developer who are working on any controller. So debugging, what sort of features that are available in debugging section, I'll just move it again. Suppose my code is getting stuck somewhere, just okay. Suppose I want to see where I want to work on breakpoints. Breakpoint means you want to go step by step debugging. Okay, so I can add a breakpoint where you want your code to be halted in order to debug. Okay, so this is the breakpoint. You have to double click on this to enable and disable. Okay, suppose I have set it here. Okay, I'll again go to the debugging section. So now what we are doing, what we are checking the feature called breakpoints. Okay, I'll play this code. See carefully, when I play this code, the code will arrive here where I have set the breakpoint. Breakpoint means now your code is halted. Okay, and you want to debug where is if any problem, if any error occurs, so you can easily check it from with the help of breakpoint. So I have added 2 breakpoints. This is the first breakpoint and this is the second breakpoint. Okay, now if I want to debug, if I want to be, if I have to debug it from the very core thing, like from very core steps of, I want to check at the register level what is going on in the code. So step into this function, step into functions will go inside this function and will let you know where is the code is, how the code is moving. Okay, first it is going in this mode. Then again, you can set up, move out of the function. It will go to the next step. Okay, so this is step info and this is step over. Suppose you want to move out of this function. See, and this time what was done, I have not gone into the inside the code. This is called step over. But if I want to check what is there in the function, I will add step in function. Okay, so it will going to give me a step by step move, how the code is moving. Okay, again go to you can say step out, step over, and you can simply remove this breakpoint using double click and you can play it. Okay, so the same code that we have run. Okay. Now one important feature that everybody would like to work on is the live watch. Okay, what is live watch? Live watch is whenever you want to see your variable, what is the value of that variable on real time basis. How you can do it? Just go to A. Remember I have initialized one function called A. I'll go to A. I'll place it here. A++. Okay, what I'm doing, I'm just adding, I'm just increasing the value of A++. Okay, and I'm just reducing it to from 1 second to 100 milliseconds, so that we can see how fast LED is blinking, and I want to see the values of A++. I'll go to project build all. I'll go to debug as. Now on the right hand side, you will see a lot of things are available, a lot of features are available. Suppose special function register, you want to check the values of register at the same time, you can check it from here. Okay, live, if you want to see the live, you can say variable, so you can see it from here. What we are doing, we have initialized A++. Okay, whether you are seeing on the left hand side expression section, whether you're able to see whether I have added A. Anyone can acknowledge? Okay, so in this A, now what I'll do, I'm going to run it. Okay, okay, the code is running and see the value of A, 18. I'll again run it, pause it, see 24. So what is it doing? You can easily check what is the real-time value of A whenever your code is working. Okay, see how it is increasing, whether everybody is able to see this. It is increasing, and you can easily check the values of now what is the application, what is the use case of this live watch. Suppose earlier what we used to do, we used to get the variable and used to display it on LCD in order to check the real values. But using this live watch, what I can do, I can simply get it from this you can say simply I can get it from this expression window. Okay, I can have a live view of the variable, the code is running, and you can see it is increasing. Okay, so this is the advantage of you can say the live watch. Whenever you connect any sensor like temperature, humidity, you want to check the values, you can check it from here. You don't have to connect any external display for the values. Okay, so this is the advantage of debugging. Okay, so this is about the basic of you can say the CubeMX and CubeID, and how to work on CubeMX is something that we have discussed. So just to give you a brief overview of what we have learned so far. Okay, so what we have, I'll just brief you all about the webinar. So today we have discussed about the basics of ARM architecture, what are the features and what are the Cortex M applications, okay, and what are the what is there in Cortex M, okay. So about ARM, it was like developed in 1990 and it was known as Advanced RISC Machine. ARM processor family is Cortex A, Cortex R, and Cortex M family. A is for high-end processing, R is for real-time processing, and M for microcontroller specific. Okay, so these are the two processor family, or you can say architecture family, in which these are the traditional controller architecture, and these were the Cortex series architectures, which was developed from scratch. Latest architecture developed by ARM is in application specific. These are the Cortex A78AE, microcontroller specific N35, real-time processing R82. So these are the latest processors that was developed. Okay, then we discuss about the Cortex. What are the series? Like first series was M0, then M0 plus, M1, M3, M4, M7. Okay. Now next is the application. What sort of application that ARM has is they are used in medical equipment, household application, automobiles, industrial application. Now the important thing was the code, the instruction set of each ARM architecture. Suppose I want to move from Cortex M0 to Cortex M3, then the instruction will be compatible. Okay, that's why we say the code compatibility in STM32. So you can easily migrate from one controller to another without changing your source code. So that is the advantage of HEL, hardware abstraction layer. Okay, you don't have to change the source code. You can simply work on from if you want to migrate, you can easily migrate from F2 to F4 or L0 to L4. So this is the thing that you can work on. Then what we discuss about the CubeMX. I'll just go to the CubeMX screen. Pinout configuration. Okay, so this is the pinout configuration. We can easily select any pin, or I can type it from here like PA6. Okay, so whatever I'll write, you will see the pin will get highlighted, and you can easily select these pins. Okay. Apart from that, you can select any timer or any CAN protocol, I2C. You can easily configure from here itself, in this application itself. Okay. In clock configuration, you can simply add the clock that you want. Suppose 64 megahertz, so I can write 64 megahertz. Accordingly, clock will be generated. In project file, you don't have to change the setting. You just have to change the if you want to change the setting, you can change it from here, but keep it as it is. You don't have to change anything from here. Okay, then the next step is to generate the code. Okay, what remember right now what we have initialized I2C. So the I2C code is available. Okay, now I2C is also initialized in the same code. You don't have to rewrite the code. You don't have to create new project. You can easily integrate from the CubeMX file. Okay, and if you see, I have written my code in this begin section and end section, so my code is saved. But if I have written this code here itself, then the code will have been deleted. Now you see, you're saying like, why did you activate USART for simple LED application? Basically, the purpose of enabling USART is to make you aware how to enable the USART. Not application specific. Application is based on LED, that is GPIO. But how to enable USART, I want to showcase that thing in the webinar. Okay, like you can select GPIO, you can select I2C, you can select USART. Okay, so this project is created in order to showcase you can enable lot of peripherals in a single code using CubeMX. Otherwise, for LED blinking mode, we don't require USART. It is just for exercise purpose. Okay, now you see any question? So why didn't you activate RCC? So RCC we have to enable when I use external crystal. Okay, I'm using internal crystal, so I don't have to activate RCC. When my application is working on external crystal, so that's when I have to that's why when I have to enable the external RCC. Okay, whenever we are working on external crystal. Okay. So Mahesh, you had having a question like 8-bit MCU and ARM MCU. So these are the two different architectures. 8-bit architecture and ARM architecture are the completely two architectures. Like for example, if you're working on 8-bit MCU, okay, you can develop small application. You won't have those flexibility which is provided by ARM. And ARM features, like if I give you the features of ARM, like it can provide you the DSP function, it can provide you the camera functions, it can provide you FSMC interfacing external RAM, interfacing external graphics. Okay, so these are the features that you can get from compare from ARM architecture. Even the latency in 8-bit, there is a lot of latency from migrating from one peripheral to another, or there is also interrupt latency which is very high in 8-bit, but in ARM MCU it is very less. So these are the two different architecture used for different applications. Okay, for small applications you can work on 8-bit, but for higher application you have to move towards the ARM MCUs. Okay. Okay. So so this is one thing. So before closing this session, I just want to give you one more demo. What's the power? Yes, I mean, data bus between two. Yes, these are the two complete different architectures. So ARM is based on AMBA protocol, and 8-bit MCU is based on something different. You can say protocol. So data bus is 32-bit in ARM STM32, whereas they are 8-bit in you can say 8-bit MCUs. Okay, so data bus is also different. So in STM32, in ARM MCUs, the data register is of 32-bit. In 8-bit MCU, it's for 8-bit. Okay, so more the number of, you can say the 32-bit architecture, you have more features, you have more flexibilities. Okay, so before ending this session, I just want to showcase one demo to you.
Before you move further, should I ask one question?
Yes, sure.
Yeah, so the thing is that can you go to the help menu?
Where?
In this software only.
Yes, just a second. Yes.
Upper one, help. Yes. Here, now there is a manage embedded software packages. Can you go to that? Actually, just wanted to know the purpose of that.
Okay, just wait. So this is something very. This is something that is very important. So if you see, what we need to do before working, because our controller is based on STM32 F4. Okay, so
yes.
F4. So I have to install these libraries from internet. Okay, right now it is installed because I have you can see the libraries are available, so I have pre-installed these libraries. But suppose I want to work in F0 library. Okay, I want to work on F0 library, then I have to install these libraries. Either I can get it from local directory where I have downloaded it, alternate is from the URL. Okay, let me give you one example. If I go to okay, so here is the package library. You have to download this package library. Okay, and from this tool you can save it anywhere. Then from the tool, from the local, you can select it from here. You just have to select it and it will get installed.
Right.
Okay.
And what is the purpose of patch there? Whether it is required or not?
Which one?
If you
patch.
If you go to the your browser.
Yes.
there are two files, right? One is a patch file and another is a
Yes,
library file.
both files will be required. So it's the
So,
updated one. But what happens is whenever you work on it get automatically installed. You don't have to install it in this way, because while generating the code, it will automatically going to install it while your code is getting update. Like before updating your code, it will get automatically installed.
yeah, right. I understood your point.
Mm-hmm.
The
Apart
thing
from
is,
that, yes,
the thing was that why I asked you this question. Na? In some of the offices like my office, where the working PC is not directly connected to the internet.
right, agree.
Right. So that is the purpose. Actually, I was initially struggling a lot.
Okay.
I found out this way, but would like to know the correct answer from you.
Okay, so there, yes. So I hope I have answered your query.
Yes. But only thing is that the patch related. Now, should I have to update the library with that patch? There, I am still confused. Actually, if I not use the patch, will still the software will work, or will it?
You have to install the patch file also, because it may have some more updated, or you can say they must have launched some new controller. So those files will be available in that patch file.
Okay. Got it.
Okay.
Yes.
Okay. So before closing this session, I just want to showcase one more demo, just for the sake of power, what sort of power the controller has. Okay, so what I'll do, I'll just build this code. I'll go to debug. Okay, so what I'm doing, I'm just playing. Okay, so this is the default code. Just let me retry it. Okay, meanwhile, I'll retry. There is a question. Can you re-explain the purpose of A++? So, I see we have used A++ just to showcase the function of live watch. Okay, the function of live watch means how you can see the variable. Like, for example, if I'm A++ is incrementing a variable by you can say by 1. Okay, A++, that means we are incrementing the particular variable. I'll just reopen. Okay, we are incrementing the variable by 1. So this is just to showcase a demo how you can see the live values of a particular variable, because in many applications you want to see you want to see the live values of your sensors. For example, you want to see the ADC value, or you want to see the temperature value. So I have just showcased this in order to give you the idea how you can watch the live values of any particular sensor. Mahesh, in STM32, you can say in 8-bit series they are having automotive grade, but in STM32 series they are not automotive, but they are low power devices which is being used. So STM32 is coming up. Maybe in the future they will have automotive qualified 32-bit controller, but they have 8-bit automotive qualified controllers. And apart from that, they are also having dual core in a single CPU. They are having dual core like Cortex M0 and you can say Cortex M4 embedded in a single chip. So they are dual core controllers that are also available. Okay. And apart from that, everyone, so that is it. Like about the session, we learned about various things about STM32. So before closing the session, I just want everyone, just a second. So everyone, just to give you about Hex N Bit. So Hex N Bit is providing professional programs in various fields. For example, embedded system and IoT, VLSI design and verification, advanced embedded system using STM32, Python programming, PCB designing, machine learning, AI ML, data science, CAD modeling, full stack web development, and embedded graphics on STM32. So we are basically worldwide recognized by ST Microelectronics for training as well as for design and development services. Okay, so if anybody is interested to join the program, they can visit our website. Okay, and for any kind of query that you all are having, we have created a WhatsApp group with you all. Okay, so in the WhatsApp group, we all can get connected, and if you have any query, you can contact the admin. I'm also available in that particular group. So if you have any questions, any technical questions, anything, you can ping me up in the WhatsApp you can contact the group admins, or you can contact me, which I'm available in the WhatsApp group itself. Just a second. So everyone, if everyone want to see our website, they can visit www.hexnbit.com. Okay, and any kind of question that you are all having, we can discuss in WhatsApp group, or you can say we can discuss it anytime via email or via call. Okay, so everyone, thank you so much for attending the webinar. I hope I've tried to give you all the information that you all to get started with STM32. In case of any query, please do let us know. We'll surely going to help you out. Okay. Any questions, anyone at the end?
Oh, I have one question actually, if you can.
Yes, please. Answer.
So can you just quickly, let's say I'm not taking much time, let's say a couple of minutes, could you please explain how to handle the interrupts in this particular, let's say how to define the interrupt and where to write the code for related, that's all. I'm not asking any application.
Okay, no issues. In the same code, I'll just showcase a demo to you. Okay. Although it's a very big topic, but I'll try to give more information. Okay.
Just give an idea, that's all.
Yes, sure. So the first step,
you need to share your screen.
Yes, I'm just sharing. Okay, so I hope it's visible.
Yes.
Okay, so let's talk about interrupt. So interrupt is suppose I have selected PC9. Okay, in PC9, if you see the last configuration GPI._EXTI9. Okay, so what we are doing, we are selecting the external interrupt connected to pin number 9. Okay, this is random. Each and every GPIO pin can act as an external interrupt. So if I select GPIO external 9, okay, so now what I've done right now, I have just configured it. I've just selected the pin to be an external interrupt. Next is how to configure this file. If I go to system overview, okay, first is the pinout view, next is system overview. If we go to system overview, remember we have selected PC9. So I'll click on NVIC. Okay. First, what I have to do, I have to select these lines. EXTL line 9:5. But because why we are doing this? Because we have selected pin on external pin number 9. Okay, so we have to select this parameter. Apart from that, this is the basic configuration. The second configuration that we have to do, we have to go to GPIO. In GPIO, I'll just yeah. So in GPIO, what we have done, we have PC9. So in PC9, what we have to do, we have to select the configuration. Now interrupt works on higher edge, level triggered, lower edge. Okay. So now what's the condition that you have to shortlist? You can do it from here. Okay, suppose you want external interrupt with rising edge trigger. Suppose you want a rising edge trigger, so you can select this one. Okay, suppose if you want the falling edge trigger from 1 to 0, you can select falling edge trigger. Okay, if you want both the edges to work as interrupt, like falling and like rising and falling, so you can select this configuration. Okay, so here is the configuration. This is how you have to do the configuration. It's very simple. Okay, any doubt in the configuration?
No, it's absolutely clear.
Okay, so next, right now what we have done, we have selected PC9. PC9, what we have first step, what we have done, we have enabled the interrupt in NVIC. Okay, we have enabled interrupt line number 9. If we have selected PC6, then again we have to enable this line. Okay, so that is an important thing. Okay, so what we have done, we have selected the pin number 9. We have configured it based on our requirement. What was that requirement? If I go to PC9, whether I want in rising edge, falling edge, or any other edge that we want. Okay, suppose I have selected a falling edge up to the application. Okay, so here now the configuration is complete. Okay, now what we have to do, we have to generate the code. Till now steps are clear. Any doubt in these steps?
No, it's clear actually.
Okay, okay. Now the next question is, now the next part is, where is the interrupt file? Where we have to write the function? Okay, so if you go to source file, okay, first step is to go to the source file. There is a file called STM32 F4XS_IT. Okay, this is the interrupt file where you have to write your question, where you have to write your you can say function. Okay, so if you go to this external number 9 and 5, here you have to write your handler and function. Anything that you want to write, you can write it from here.
Okay, got it.
Okay,
yes.
So there are multiple ways to define an interrupt. This is one way. Another way is to work on callback functions. Okay, that is another way. That is a big you can say topic.
Yes,
we can definitely.
But this is, I think, most simpler probably.
Yeah. So you have to select the line, because this is a common function for an external interrupt 9 to 5, pin number 9 to 5. So you have to select the line number, and your interrupt will be enabled. Any function that you want on pin number 9, you can enable it.
Okay.
Okay.
Right.
I hope I have answered your query.
Yes.
Okay.
Only one thing actually, how to define the priority. If there are, let's say, 5-6 interrupts are there.
Right.
Suppose I have 5-6 interrupts are there in my application. So I need to define the priority. That setting might be there in NVIC only, right?
Yes. See below. So preemption, priority, sub priority. You can select it from here.
Okay, got it.
Okay.
Yes.
So you can easily select it from here. So preemption, sub priority, everything is available in the CubeMX file itself.
Okay.
Okay.
Thank you. I'm clear now.
Okay. Thank you so much. Okay. Yes, Nicey, you want to say something?
Yes, and thank you very much for your time and for this webinar. Can you hear me?
Yeah, perfectly audible.
Okay, yes, it was a great pleasure to be part of you today. And I am a student living in France here.
Okay.
So I am studying with a kind of what we call here by a sandwich course. It means you have a period of time at school and another period of time in a company. So today I am dealing with STM32, and it is really interesting to me to deal with this kind of software, management with this MCU. So one of my challenge today, because I have already contacted the exhibit community so that we can see together how I can move forward. I mean, I can get developed from your expertise. So my concern today is about I2C because I have some difficulties to read data sheets from, for example, I2C sensors and so on. And the second concern is about CAN bus protocol, which is really today required and the skills that companies are crying out for from people who want to be hired. And it is about J1939. And these two entities, I mean, I2C and CAN bus protocol, if I can know more about it, I am going to be I will definitely be part of the exhibit. People who are going to enroll.
Sure, definitely. We can support you in the I2C, and you could say you want in Canvas. Definitely, we are having excellent expertise in these peripherals, so we can support you in this. Definitely, we can discuss it offline. Like we can have a discussion on this, or we can have a call whenever you are available to have a detailed discussion on this and how we can resolve your query. Okay, would that be okay, Nice?
Okay, thank you so much. Okay, thank you so much, sir.
Okay, thank you. I hope everyone, you all have learned, you have gained some of the knowledge from these sessions. Okay, we'll come up with the upcoming more series of STM32 in the upcoming time. So we'll share in the WhatsApp group for this session. And after this session, you're going to receive one feedback from, so that will help us to improve and to get motivated to come up with new programs, with new, you can say, webinars. So please share your feedbacks. We'll share the feedback form with you in a short while. Okay, everyone. So it was nice. It was really nice and interactive session. I hope everyone has enjoyed and learned a lot of things. So take care, everyone. Bye bye. For any issue, we'll be help you out in the WhatsApp group or in the email ID itself. Okay, everyone. So take care. Bye bye.
Bye. Thank you.
Thank you so much.